So first of all, you need to know what probability means, right? So probability is a numerical measure of the likelihood or chance of occurrence of an event. That is what probability means. And the range of probability is 0 to 1. That means the probability of happening something should be in between 0 and 1. It cannot be less than 0. It cannot be more than 1. It has to be between 0 and 1. So that's the main probability rule, right? And there are different probability terms. So let's see what those probability terms are. So when it comes to basics of probability, it's important that you know these probability terms. So the first term is that random experiment. You need to know what a random experiment means. So random experiment means an activity in which the outcome is not perfectly predictable until its completion. So in a random experiment, outcome is not perfectly predictable. Is not perfectly predictable until its completion. For example, tossing a coin. So when you toss a coin, you don't know whether you will get head or tail. So outcome is not perfectly predictable until it's complete. So that's called a random experiment. Then you need to know about the sample space. Second term is sample space. So this can be represented by S. This means the set of all possible outcomes of a random experiment which you can get is called sample space. So for example, if 2 coins are tossed, the sample space you can write like this. S equals the probability of getting head in both the coins, tail in both coins, head in one coin and tail in the other coin, tail in the first coin and head in the second coin. So this is the sample space, all possible outcomes of an event. And this sample space you can even represent it in a chart like this. So here you can say first coin and the second coin. You can mark tail, head, tail. So this shows all the possible sample points which you can get. You can get head and tail, tail, and tail, head. Likewise, it shows all the sample points which you can get by tossing 2 coins. And at the same time, you can also show in a tree diagram like this. So you can say head, tail, getting head and tail in the first coin, and getting head and tail in the second coin. Right? So like this also you can show in a form of a tree diagram. Okay, so now we'll start Venn diagrams. So what is a Venn diagram? It's a pictorial representation of combination of 2 or more sets. So sample space is denoted by a rectangle and subsets are represented by bicircles. So for example, if A and B are 2 sets defined in the same sample space, let's say you have 2 events as A and B, which is defined in the same sample space, then you can say the set union, which means occurring at least A or B. This can be represented by a Venn diagram like this. You have A, B. So the probability of A union B means occurring at least A or B, which means this area. So here you can write A union B. So this is how you represent set union. And at the same time, if the two events A and B are mutually exclusive, mutually exclusive, which means occurring of one event affects the occurring of another event. That means both events cannot happen at the same time. They are called mutually exclusive events. So in that kind of situation, these two circles will not be joined, but they are disjoint. Right? So in that kind of situation, you can write A union B which is this area, like this. So this shows the probability of occurring A, O, P. This word O is very important. It represents union, right? And next we move to set intersection. This is the event which represents the simultaneous occurrence of A and B. Okay, A and B. So this one you can represent using a Venn diagram like this. You have events A and B. So intersection means this part. So you can write this is A intersection B. And if the two events are mutually exclusive, what will happen? Do you have an intersection point? No. So in this kind of situation, when the events are mutually exclusive, you don't have an intersection. So probability of A intersection B will be equals to 0. Okay. The next part is set complement. So how you can represent set complement? So this is the event which represents the non-occurrence of the event considered. So if you draw the Venn diagram as A and B, how you can draw A complement? That means the probability of not occurring A, which means this area. The outside area except A, that is called A complement. And if the two events are mutually exclusive, which means disjoint, so in that case, A dash, or what we call A complement, means this area. Then the next part is set difference. This is the event which represents the difference of two events or the occurrence of only one event. So you have A and B. has the two events. Let's say A minus B which will be equals to A intersection B dash, which means this area. And also you have two events A and B. And if you want to get B minus A, it will be equals to A dash intersection B, which means this area. From B, you deduct A, which means you deduct this middle part and you remain only with this part. So that will be equals to A intersection A dash intersection B. That means except A, whatever the portion you have for B is for A dash intersection. So that's all about the Venn diagrams. So next part we'll be starting with another video. So have a nice day today.